So if you've ever done the speed of sound lab, for example, here's somebody else's picture, you often set it up with the water and the open end so that you can get a quarter of a wavelength for the fundamental. And you want to be able to quickly get what the lengths of the tube should be, the air column in the tube, without having to do the math yourself. This Desmos should let you do that. So you can set certain parameters, like 1/4 here for a fixed open. If you want to include a correction to tack on to the end of the measurement for the width of the tube. So instead of the wavelength being 4 times the length you measure, it'd be 4 times the length you measure plus whatever you tack on here. You can set the temperature in degrees Celsius. It'll give it to you in Fahrenheit. It computes the theoretical speed of sound and in miles an hour. So then we'll hide that. It will compute the wavelength that you need, V equals F lambda, and the X for the tube, how long that air column should be, including the correction factor. I should say without the correction factor. So how long, what's the student going to measure on the tube? And there's this little inspection button, so green, so you can change the frequency and see what the length should be to just read it off of there. Now sometimes students will get values that don't seem to match. And if you're curious if it could be some higher harmonics, if you drag this harmonic slider, it will actually show you higher harmonics. So because this is a quarter wavelength, fixed open, this is going to be the first, the third, the fifth, because in theory, you're not supposed to get even harmonics. Now let's say you were to repeat this experiment, but with an open tube, maybe one of those whirly tubes or something. Then you move the slider to a half, meaning half a wavelength in the fundamental, and it will show you the odds, which are the solid lines, and the blues, which are the dashed lines, and you can inspect and get the values there. You can also get a table of the inspection values here, so you can read that. I've also included half harmonics only because I know from looking at tuning forks and things like that I often see half harmonics. I don't know why, but I know I sometimes see them there. Probably somebody who knows more about music could tell me. If you want to see what those half harmonics would look like, I put those in as dotted lines. But that starts to get pretty confusing, so let me turn that off. Let me turn the number of harmonics down to just, say, 3. See if we're catching the next harmonic. So I included a section that says enter lab data here. So actual measurements that you might take. You just type in the raw frequency, which usually would be the tuning fork or whatever you're using to drive it, and then the X at which you got the resonance. And if you select this, it will actually put the dots on the screen. So these blue dots are, I made them up, they're not real, but these could be your real data points. And finally, if you go to this measured speed versus theoretical speed, what it does is it actually does a fit to linearize the data. I just put that back to quarter wavelength, so fixed open. Now let's look at the data again. Which it does this fit. This is just sort of a rearrangement of V equals F lambda. And Desmos computes this automatically. You don't need to actively do anything. And then I have it subtract the difference and figure out the percent difference right on the fly. Suppose I could have worked this backwards and try to get the measured temperature from the speed of sound, but you have to stop at some point. Now if I go back to here, let me drag this out of the way, so this will move the inspection point off, so declutters it. By the way, this just changes the range over which you're showing the graph. Let's show just a few more harmonics, say to the 5th, and it's kind of fun to watch. If I change the temperature, you can actually see these lines shift as the new theoretical speed of sound changes. So this is kind of a quick way as a teacher to check student data, or maybe collect your own data and see how close the temperature comes, or I don't know, thought it might be useful. It was fun for me.